Okay, so thank you very much for having me here. My name is Zoe Coull. I'm a corrosion engineer and have been working in this space since my undergraduate degree at Imperial in the UK. I moved over to Canada 15 years ago, believe it or not now, to do my PhD also in corrosion at U of T. I then worked for a few years in consultancy, and 3 years ago I actually started my own company. And if you're wondering where the name came from, because people often do, he's nodding. I was sitting at my kitchen table trying to figure out a good name for the company. My kids were there. Every single name I came up with, they were like, "No, Mum, that's rubbish. Don't use that one." And so eventually I got fed up with them and said, "Okay, you come up with something better." And they did. So, so that's where the name comes from. So I'm going to be talking to you today about my fascinating world of rust. And what I'm hoping to do is convince you at the end of this presentation that what we need to be doing is using proactive, systematic corrosion control planning to safeguard our mines, our businesses, our communities, our people, and our environment. So in terms of innovation, we're not going to be talking about something new. What we're actually talking about is borrowing something, processes namely, and best practices from other industries, namely oil and gas, also automotive, military, stealing them and bringing them in and adopting them for mining. So, if we can get it to work.
No promises.
No promises. Okay, so the areas that I want to discuss are not 3 areas, but there are 4. We're going to have a quick look at some corrosion examples in mining. Then we're going to look at very, very high level how corrosion is associated with different risks. Then I'm going to introduce you to strategic corrosion risk management. And then actually at the end I've got a case study of a project that we've been working on for the last year. Corrosion in mining. So whenever a corrosion engineer walks onto a site, a mining site, it's almost a little bit like opening a textbook of corrosion problems. We have a lot of different things going on here. A lot of these problems that we see are actually associated with the water that's being used, either in the process or around the coast, or we also have things like atmospheric corrosion that attacks our structural steel. We've got conveyance lines, we've got all kinds of things going on there, lots of different kinds of corrosion. So for those of you who think rust is just rust and it's a bit annoying because it's on my car, it's not. There are lots of different mechanisms of corrosion. So I just want to share a few of these with you. So this is an example of erosion corrosion. So this is where you get abrasion plus an acidic environment, for example. This damage was done over 4 weeks in a crusher. Atmospheric corrosion of structural steel. So this is very dependent on the atmosphere that it's in, the exposure conditions. Galvanic corrosion, very exciting. This is where you put 2 dissimilar metals together, and in this case we've got carbon steel in a stainless steel flange. One of my favorites is where you get scaling and also microbially influenced corrosion. So this is where bugs actually cause corrosion in your assets, and it can cause quite significant damage. This was from a stainless steel process plant. After 1 year of operation, we'd already lost half the wall thickness in some of the welded areas. So just to give you a few examples, if we move up from the sort of technical piece of this and look at the risks overall, the statistic I like to start with is how much does corrosion cost us? So this is actually a statistic from the National Association of Corrosion Engineers. Yes, there are more than just me. But they actually went out and they calculated how much all different kinds of industries spend on corrosion annually. And they came up with this enormous number, 2.5 trillion US a year, which is more than the GDP of Canada and is only half the story. This is the direct costs in terms of replacement and corrosion control. They calculate that indirect costs are actually around the same order of magnitude. So this is where we have things like erosion of business value from production losses, for example. Just to give you an example, this is the same process tank that I showed you earlier with the weld that had been kind of eaten out by the bugs. The repair itself only cost around 100K to repair this tank. but because it was offline for so long, the client was actually losing 250K a day. So by the time we got it fixed, we were looking at over 5 million in downtime costs. But it's not just costs. I mean, those are kind of the easiest things to kind of measure, but corrosion also links into other risks. And this doesn't just necessarily, this isn't necessarily just for mining either. This can be across different industries. So let's look in a little bit more detail at environmental and health and safety. And again, I just want to bring this up a level. It's not just mining that has these problems, but it's also infrastructure. I actually started my career off looking at highway infrastructure in the UK. This is a recent example of what happens when corrosion goes unchecked. We don't really need to go much further past the first line there. We lost 43 people in this recent bridge collapse. Corrosion's not the only cause, of course, but it's one of the important ones. We have structural collapses in mining as well, and these have, on occasion, also caused fatalities. This is a conveyor gallery collapse at a potash facility. The day before, they had a tour of school children going through this gallery, so it was a near miss. Environmental, well, again, if we look at other industries, we look at oil and gas. That's always the one that's in the news. Pipeline corrosion is actually one of the biggest leading causes of pipeline failures. And obviously we have a lot of effects on the environment from these types of failures. Similarly in mining, so this is an example of the San Marco tailings dam failure. I don't know if that had anything to do with corrosion, but what I do know is with tailing dam facilities, we don't have corrosion input into design. We don't have standards that look at maintenance, inspection, and monitoring from the corrosion perspective. And as we know, it was a devastating incident. So why are these kinds of disasters still happening? Because I've been giving these kinds of presentations for quite some time now. I wouldn't say quite decades, but we're getting there. So it's, why are these things still happening? Well, again, it's not just mining. This is what I want to keep emphasizing. It's not just mining that's dealing with these things, but there are some themes across all industries that we have to pick out. The first and probably most important one is that we don't look at corrosion risk in a strategic way. We don't track the right things. And so if we don't have the data, we can't make data-informed decisions about how we're controlling the risk. The second thing is around skill set. So when I did my undergraduate degree in materials, we had half a course on corrosion, and the professor seemed to be more interested in teaching us about corrosion in space, which, while very interesting, wasn't particularly useful. And unfortunately, we find that with a lot of engineering programs, that corrosion isn't necessarily an inherent part of what engineers are learning. So there's a knowledge gap. And then finally, innovation. So when people are not aware of the risks, they're also not aware of the controls and the technology that's available to control those risks. So again, an example, we've been talking to highway infrastructure with cell phone technology for 2 decades now. But this is, since I think the first project that we've managed to do in Canada was last year on that same technology, bringing it into a new build gold mine. So, and this slide really sums up my kind of evolution in terms of my career. I started out as a very, very technical person. I look at the technical problem, I understand it in detail, and I come up and design a solution, and I think, yes, the solution is solved. We have the solution. Everything should be great. But it's actually not as simple as that. What I've realized is that in order to holistically solve the corrosion issues, we've actually got to shift the culture. We've got to shift the way in which we think. And that will become, as I go through the case study, I'll be able to kind of show you that in a bit more detail.
Did you get your kids to draw this one?
I drew that. How dare you? I also drew this one. And so just to sort of go on from that, as engineers, we're trained to look after this technical solution piece. But what I'm saying is that unless we think of things like the direction, the policy, where are we going, why do we want to do that, what do we want to achieve, management systems, how do we keep our controls working, how do we know it's working, what are the metrics we need to be tracking, and then also very, very importantly, who are the stakeholders, who's involved, what do they need, if we don't have all of these different things, we're not going to solve the problem. And this is what we'll end up with. We'll end up with a situation where we think we are looking and we're solving the problem, but actually we're not seeing the full picture. So I want to go through, give you a bit of an introduction to strategic corrosion risk management. So like I said, this is something that we are not, well, I suppose we're being given a gift, but I kind of look at it as we're kind of stealing these processes and ways of thinking from other industries that are a little further ahead, such as oil and gas, where there are a lot of regulations around corrosion, so it tends to be more built in. Automotive, and also military. So a lot of what we're going to talk about came from the US military. So what is a corrosion control management plan? It's actually very simple. It's really just a set of processes that allow a company to manage the risks around corrosion for their assets. That's all it is. Sounds awfully simple. Why haven't we been doing this before, Zoe? I don't know. So really, this is the framework around that has been developed from the best practices that have been pulled from these other industries. So again, it's not really, really what we have in the middle is our technical piece where we figure out what the problem is, we solve it, we monitor it. So we're not really going to concentrate really very much on that middle piece. What I'd like to draw everyone's attention to is what we have around the edge, the management section. So before we get into that in detail, where did this all come from? Well, the first reported corrosion control management plan was actually put together in 2002 by the US Marines. So this Deputy Commandant, Richard, God bless him, decided that corrosion was actually affecting the safety of the troops on the front line. It had nothing to do with, isn't rust annoying, aren't our cars are falling to bits. It wasn't anything to do with that, it was to do with the safety of the Marines. And he actually mandated that a very structured corrosion control management plan was put together. And within 4 years of initiating the program, it saved them 15% of their maintenance budget and decreased their sort of hours spent on corrosion maintenance a lot as well. Importantly, it did also improve the safety of the troops at the front line, which was the whole point in the first place. So we kind of developed it from there, and just to kind of move forward a few years to 2016, again, NACE took it upon themselves to carry out a survey of 243 companies. Incidentally, not one of those 243 companies came from the mining space. None. Zero. We're trying to change that. So if anyone is interested in taking part in this survey, let me know. But what they did is they went to all these different companies, and what they were doing was they wanted to pull out what they were doing in terms of corrosion risk management, who was doing what well, what was working, what wasn't, and they pulled it all together into this report called the Impact Report. And that's really where we take our best practices from. Really what this best practice document is trying to do is it's trying to move the industries, all of them, from this reactive ad hoc approach to corrosion control management to creating a structure to finally getting to holistic corrosion control. Most of the companies surveyed are still here. Only 14% of the companies surveyed said that their CCMP was robust. So we're not late to the game here. No one else is doing this particularly well either, to be quite honest. But we do have this good framework that we can start with. So how does this process help us to protect mines, businesses, people, the environment? What I'd like to do now is go through a little bit of a case study. Does anyone have any questions at this point? Okay. So this project is a project that I've been involved with since about a year ago. We started this project, and the site in question. They had some corrosion issues. They'd already started to put together a corrosion team at the site. They had some structure around how they were doing this. And then they realized that the team was actually they had a firefighting approach to dealing with the different issues that were coming up. So they were going over here and they were fixing that. And then there was a bigger fire over there and they fixed that. And so what they were lacking was a strategic approach to this. They couldn't really get their hands around what their risk to the business was. And so that's why we decided to do, first of all, a gap analysis. We wanted to see what they'd got already versus the best practices. And so this gave us a list of priorities of areas where we wanted to start first. So we're kind of almost at the end of year 1. So these are the areas we decided to start with. And then year 2, this is still the work that still has to be done. So I'm going to go through each of these. So just to give you a bit more background on the issues that we had in each one of those buckets. Technical, unfortunately, it was like I said at the beginning, you kind of walk onto the site and there are a number of different problems, right? Unfortunately, for this particular project, corrosion had not been considered at the design phase of the project. I wouldn't go as far as to say it had been completely ignored, but a lot of the issues there are going to be with the plant. It's going to be a legacy that they have to deal with, unfortunately, which goes to show the importance of actually including corrosion at the beginning. Don't design it, please, without corrosion engineering. In terms of policy, like I said, there was a lack of strategic approach when it came to dealing with the risk. They weren't measuring the right things. They weren't then able to use those data to prioritize what work they were doing to fix it. In terms of communication, and often I think you find this on sites, is that we had teams that were very siloed, and there wasn't a lot of information flowing between the different teams inside the company and outside the company. In terms of risk management, obviously the site was using a very standard kind of risk management approach with a risk matrix, etc., but there wasn't an input for corrosion. Again, on risk management, we had some lessons learned being shared, but mostly within the internal group and not beyond. Training, again, within the core group, the training levels were actually quite high. The core group itself of 2 or 3 people were doing fine with the training, but that information, that knowledge was not making it out to the general population. And then finally, when it comes to the technology piece, this core team, because they weren't corrosion engineers to start off with, they were having to start from scratch to go and see if they could find different technologies to solve the problems. So for each of these, I'm going to tell you what the best practice is, and then I'm going to tell you what we did. So policy, the best practice is that a CCMP should have clear and meaningful KPIs. It's the most important thing. It forms the backbone of everything we're trying to do here. And those obviously should align with what the organization is trying to achieve. I can't give you, graphs of data here, but I can tell you some of the things that we've been tracking since the start of the year. Cost of corrosion. This was not being separated out, so we knew it was costing something. So if I asked you, like, what are you spending on corrosion, would you be able to answer that question? It's only happened once. It's only happened once. We're tracking things like asset availability versus nameplate availability. We're looking at percentage of work order compliance. We're looking at total man hours on corrosion. We're listing health, safety, and environmental risks, plus a whole list of other things that were not being tracked before, that we had no visibility on. So I always like that question. How much are you spending on corrosion? Because everyone kind of looks at me blankly. I don't know. Communication. A vital component of a CCMP and best practices is having a well-defined communication protocol. And this really means making sure that we identify all the different stakeholders that are involved in this project and making sure we know where the information is flowing to, where it's flowing from, making sure people are informed. So what we did with this one is, instead of using the sort of hierarchical organization chart, which doesn't really show you how information flows, we used a social networking tool. So each one of these blue nodes is a person, as a stakeholder. We mapped them out and we figured out who was communicating with who, and we did an analysis on this network to figure out, first of all, we used this to help us develop the communication plan, but secondly, we also used this to identify weak points in that map. For example, this lady here, If she decides to leave or move positions, we've lost half of our communication network. So what we've done there is we've actually put some redundancy into that role. So that's how we use that one. Risk management. We should be using recognized standards to have a systematic process for developing risk tracking, right? So we've actually been doing this. We've got a system set up for the tanks and vessels. We're currently working on structural steel and civil structures, and the next on our list is piping. So just to give you an idea of what we did with the structural steel, we actually used a standard, an ASTM standard, D610, which gives us a visual representation of how we can put a semi-quantitative risk value to a visual inspection. We've actually simplified it a little bit, but it is based on this standard. But what that means is that we can now take all of our structural assets and actually prioritize them and track how they're doing over time. We're no longer so dependent on a subjective visual inspection to help us to do that. We've standardized it. Training and competency. Well, I'd say the sort of first best practice here is making sure that our corrosion team has the right training, which in this case they did. But more broadly, if you're sort of trying to achieve something with a small group of people and someone else somewhere is, not using the right coatings, or they're leaving things lying around, or the housekeeping's no good, it's kind of thwarting your efforts, right? So what we've done here is we've actually developed a site-wide awareness training program. We're currently rolling that out to 800 staff. So it's now been built into as a core competency in their training programs. And then finally, we know from other corrosion control management programs that we can save 15 to 35% of maintenance budgets just using technology that already exists, adjacent technology. So when I'm sort of saying, I started my career off in the highways infrastructure sector and moved into mining, again, it's taking the technology that they've got there and actually bringing it into mining. So we have it's not this project, but we're about to do it with this project too. There's a new build mine that we were involved with in northern Canada. They were concerned about the use of saline water as washdown on their concrete structures. So what we've done is we've embedded corrosion rate monitoring probes into their structures so that they now have a read on what their risk is over time. They can plug that into service life prediction modeling. They can use that to schedule repairs, prioritize repairs, all kinds of things. So the technology exists, we just aren't using it yet. So in terms of this particular project, we're looking at a lot of different technologies here. Corrosion monitoring is kind of one of my big things, because if you're not measuring your risk, you're not tracking it, you don't know what it is. But we're also looking at things like corrosion inhibitors and different kinds of coatings, and also cathodic protection. One thing that they picked up on quite early on was APM software. So this is where you're essentially digitizing your inspections. And I think quite a lot of people are probably using these now, but it's been a huge benefit to this particular project. Everything has speeded up. We know where the information is, and there are a lot of tools within that allow us to do automatic service life prediction modeling and that kind of thing. So just to kind of summarize where we've got to in the middle of this project, we've still obviously got a year to go here. We've now got data, which is amazing. We've got data, we've got KPI data that we've decided at the beginning of the year, what are we going to measure? Why are we measuring it? Let's measure it. And that's what we're doing. So we're actually going to be sitting down in December to figure out, do an analysis on those data, figure out what our performance targets are. We're going to use those data to help us decide where we're going to put effort, how we're going to prioritize, how we're going to budget, all of these great things that we weren't able to do with very much accuracy before. We've got a communication plan that's in implementation, so we're also going to be reviewing that soon. But we're already seeing that there's a much better linkage between different areas of the plant. The risk management, this is still ongoing. Obviously, we've got a system for the tanks and the vessels, the structural steels next, concrete, all these exciting things. Piping is coming up next, which will be an interesting one. Training, like I said, we're hoping to have the majority of the staff awareness trained in the next couple of months, and this is a program that will repeat every year. And then finally, you know, in the technology space, so I didn't talk about it quite so much, but we've got a lot of kind of interesting things happening there that are going to be first time for mining in this particular project. So I think that's almost it, but the summary really is to send you away with this idea that corrosion risk in mining is actually quite serious. It does have implications for cost, production. It does also have implications for the environment, health and safety. But we do have the technical solutions. We already have the technical solutions available. We just need to start using them. The bigger problem is around how do we shift the culture? How do we shift the thought process behind how we deal with this risk? If we use the technology and we use, you know, the corrosion control management planning, which I believe is a great tool for shifting the culture, we're going to safeguard ourselves from the corrosion risk. And I wanted to leave you with, I tried to look for a quote from the current president, but wasn't able to find anything wasn't able to find anything quite as inspiring as this. So I remember being at one of these talks a while ago, and someone in the audience said, you know, we always get together, we talk about innovation, but nobody ever does anything. And I'm just saying, look, we are doing things. We are doing things. We are trying to be the change, and really that change in the culture around corrosion risk in mining is why my company exists. It's why I get up in the morning. So I hope that you enjoyed that, and obviously if you've got questions, please feel free.